Hello everyone and welcome back again. Today we have an interesting question on projectile motion. Let's do justice to it. The question reads, a ball is projected at an angle of 45 degrees to the horizontal. If the horizontal range is 10 meters, find the maximum height attained by the ball. And we were told to take g as 10 meters per second square. Okay, so this is a case I love to call case 1, where the object is projected at some point and it also lands at the same point. For case 1, the ball or the projectile is not launched off a cliff. So if it's launched off a cliff, the general formulas for case 1 does not work, or they don't apply in that case. For example, let's suppose here that we have a cliff and then this is like a hill or something, and then the ball is projected from the hill and it lands on the ground. So this case is different from this one. So the general formulas for case 1 only work for case 1. They don't apply here. And I'm going to show you the formulas that I'm talking about. So what are they? So to calculate, I will say important formulas for case 1. So for this case here, the ball is projected at some point and it also lands at the same point. Okay? You can see the same level, no difference. It did not land earlier, it didn't land, let's say, lower. Okay? It's just on the same plane. So to calculate the time taken to reach the maximum height, so this is time taken to reach the maximum height. We say it's small letter t. This is equal to u sine theta over g. So you can also call the u your v0, where the u is your initial velocity. Okay? Now for the time taken to travel, the total time taken to travel, or the time of the motion, we say 2u sine theta all over g. So this one here is the time, the total time taken to travel from the point of projection, which is here, to the plane of impact, which is here. Now, the next one is the formula for the maximum height, which is h max. So the formula is u squared sine squared theta all over 2g. So with this formula here, you can calculate the maximum height attained by the projectile. And that's actually what they want us to find. Now, the next one that you need to know is the range. So the range is simply the maximum horizontal distance from the point of projection until it falls to the ground. So the distance between the point of projection until it lands, it is called the range. While the maximum height, okay, you can see is the peak of the trajectory. So this point here is the maximum height. So to calculate the range, the formula for this case is u squared sine 2 theta all over g. So these are the 4 important formulas that apply in case 1. These formulas does not apply here. They don't apply here. Don't forget, they only apply in case 1 when the object is projected and lands on the same plane. So they say we should find the maximum height. Okay, so let's solve the question together. Here we have the range to be 10 meters. We have our theta to be 45 degrees. Okay, were we given the initial velocity? No. So we have our g. Our g is 10 meters per second square. All right. Now, what do we do in this case? We have the h max. So the h max here, the formula for the h max is equal to u squared sine squared theta all over 2g. Now, let's see if we can work directly with this formula using the given parameters. We have our theta, which is 45 degrees. We have our g. We don't have the initial velocity. So this is now a problem. That means that we need to find the initial velocity first and then plug it into this formula before we can get the maximum height. Now let's look at the formula for the range since we were given our range. So for the range, we have u squared sine 2 theta all over g. Do we have the range? Yes, it's here. Do we have our theta? Yes, it's here. Do you have our g? Yes. So we can find the initial velocity, which is the only unknown here, and then plug it right into this very formula to solve for the maximum height. So let's do just that. Here we have that the range is equal to u squared sine 2 theta all over g. So I'm going to cross multiply to solve for u squared. When I cross multiply, I have u squared sine 2 theta is equal to gr when you cross multiply. Now we divide both sides by sine 2 theta, sine 2 theta, so they cancel out. We now have that u squared is equal to gr over sine 2 theta. To solve for u squared, we simply square both sides to remove this square here. So this square cancels out with this. We have that our u is equal to the square root of gr over sine 2 theta. We can now plug in our values and solve. Our g is 10. Our range is 10 over, we have sine, our theta is 45, so this now becomes 2 times 45. Simplifying, we have our u is equal to the square root. 10 times 10 is 100 over 2 times 45 is 90, so we now have sine 90. We now have the square root of 100 over sine 90 is 1. And this gives us the square root of 100. And when we simplify further, the square root of 100 is simply a 10. So our initial velocity is 10 meters per second. So u is equal to 10 meters per second. So having found the initial velocity, let's now calculate the maximum height. We say h max is equal to u squared sine squared theta over 2g. This is equal to, our u is 10, this becomes 10 squared. So this sine squared theta can be written as sine theta all squared. Okay, so first you evaluate the trig function and then you square the result. So this now becomes sine, our theta is 45, so we have 45 all squared, and this is over 2 multiplied by 10. 10 squared is 100. Sine 45 is root 2 over 2. Okay, and then we square everything. This is over 2 times 10 is 20. So the maximum height is equal to 100. So we distribute this square, cancels out with the square. So we're now left with 2 over 2 to the power of 2. That gives us a 4 over 20. So 2 go into itself 1, 2 go into 4, 2. So we now have 100 multiplied by 1 over 2. So if you punch sine 45 on your calculator, you're going to get root 2 over 2. And when you square the result, it will give you 1 over 2, okay, over 20. Again, 100 times half is 50. and this is over 20. So the maximum height h max is equal to 50 divided by 20 is 2.5, and the unit is in meters. This is the solution, and I thank you for watching this video. See you and bye.